So now I'm going to talk more specifically about potential energies and changes in potential energy. Charges exert forces on one another, and the magnitude of those forces is position dependent. So there is a position dependent energy, which we call potential energy. Opposite charges tend to fall towards one another, and when we allow them to do that, they gain kinetic energy. Like charges tend to fall away from each other, gaining kinetic energy. So by agreement, for many of the important cases that we'll work on here, we assume that the potential energy equals 0 for r equals infinity. And like charges that are closer together have a positive potential energy, and unlike charges that are closer together have a negative potential energy. So calculating changes in the field. So we have some arbitrary field E here, and we're going to find the change in energy. So if we had a positive charge that we're free to move and we placed it at A in this diagram, it would experience a force and it would gain kinetic energy as it moved from A towards B. That would happen in the absence of an external force. And it would gain energy as it did so. So it would have converted that potential energy into something else, and if there's nothing slowing it down, like, say, viscosity or something, it is going to express itself as kinetic energy, so you'd have this exchange between potential and kinetic energy. The change in potential energy is equal to the work done on the field. Okay. Change in potential energy is equal to the work done on the field, which is the negative of the work done by the field. So in this case, the work done on the field, change in potential energy, this force is some arbitrary external force, and the negative paired with the QE is the field. And that's where this negative sign comes from. The Q is, of course, going to be constant. We could factor that out in front. And that would give us the change in potential energy is negative Q integral from A to B E dot ds. This E dot ds term is going to become very familiar to you over the course of the next week or two.